2003 Grade 9 Friar Math Contest. The marks of 32 mathematics students on Test 1 are all multiples of 10 and are shown on the bar graph. What is the average mark of 32 students in the class? We have to therefore just look at this graph, and first let's see, there's one student here, 2, 1, 4. I'm just looking at this side of the graph. 6, 9, 4, and 3, right? So we just have to use those numbers to calculate the sum, which would be one student that scored 10, two students that scored 30, two students that scored 40, one student that scored 50, four students that scored 60, six students that scored 70, 9 students that scored 80, 4 that scored 90, and finally 3 that scored 100. And then, of course, we have to divide by 32 because that's how many students are in the class. So you crunch out these numbers. I'll let you do it. When you do, it comes to 2240 over 32, and that is exactly 70. B. After 6 tests, Paul has an average of 86. What will be his average if he scores 100 on the next test? Okay, so the first 6 tests, his average is 86. So the sum of all those will be 6 times 86. And then you have to add to that the next test, which he scored 100, or at least that's the scenario. And then the average, of course, you divide by how many tests, where there was 6 tests and then there was one additional test, so 7. And that's basically the calculation. So this is 516 plus 100 over 7, and that's 616 over 7, and that comes out to exactly 88. And we have the next part. Later in the year, Mary realizes that she needs a mark of 100 on the next test in order to achieve an average of 90 for all her tests. However, if she gets a mark of 70 on the next test, her average will be 87. After she writes the next test, how many tests will she have written? Okay, so there's 2 scenarios here. So the first scenario is 90 times n, where n is the number of tests. That's the total score that basically she would have. Now that scenario happens if the first n minus 1 tests have a certain score, and then you add 100, which is what they're doing. And then, of course, you got to divide by the total number of tests, which is n, and they're saying that average is 90. So this is basically the equation that you create with that first sentence. The second sentence be very similar. The total score, let's just write that in here, total score. For the second sentence, this one right here, that whole thing, will be 87n. 87n. So how do we get that? Well, equation 2, basically n minus 1 times a certain number that we don't know yet, whatever it is. And then you add to that 70 this time. And then, of course, you divide by n, and they're saying that average is 87. So this is basically the 2 equations we have to use to solve for n. Okay, so here we go. So equation number 1, if we cross multiply, we get n minus 1 times x plus 100 is equal to 90n. And the equation number 2, if we cross multiply, we get n minus 1x plus 70 is equal to 87n. And then we can just subtract them. So this becomes 3n, and this is just 30. And then therefore n is going to be 10. And that is the answer to this question. Number 2, in a game, Xavier and Yolanda take turns calling out whole numbers. The first number called must be a whole number between and including 1 and 9. Each number called after the first must be a whole number which is 1 to 10 greater than the previous number called. Part A. The first time the game is played, the person who calls the number 15 is the winner. Explain why Xavier has a winning strategy if he goes first and calls a 4. So let's talk about this. We have it Xavier and Yolanda. So Xavier is going first and calls a 4. So we have to figure out a winning strategy. Okay. Well, we got to mess around with this, see what kind of guaranteed situation would be a winning strategy. So I'm going to write up all the numbers. Now, the next number has to be 1 to 10 greater. So the maximum we can go is 10 greater, which would be 4 plus 10, which is 14. So let's go all the way up to 14. 8, 9, 10, 11, 12, 13, 14. That's the maximum. I'll put in a 15 in here, but 15 cannot be used. Or let's see here. Okay. So the next number is called by y, right? So let's make a little table here. Let's make a little table and let's see what kind of scenarios we get. So we have what y calls, and first of all, is that possible? And then what will x call? X to win will call the number, and then we'll fill it in. Okay, so let's see what will happen. Okay, so we already know that x is going to call this 4. Now it's y's turn. So I'm going to start with the maximum here. I'm going to actually start on that end. Can y call a 15? And the answer is no. Why? Because 15 is 11 more than 4, and we can only go as high as 10 according to the question. So that's not possible. So this case we don't even care about. So just put a dash there. Okay, let's keep going. Can y call a 14? And the answer is yes, because 14 is 10 more than the previous number, so that is part of the criteria. Okay, so if that is true, what does x need to call? Well, x needs to call 15, obviously, to win. And can he do that? And the answer is yes, because 15 is only 1 more than 14. And that's part of the criteria, that the number that is called has to be anywhere from 1 to 10 greater than the previous number. So that is a perfectly legitimate scenario. Got it? Okay, let's keep going here. So 13, can y call that number? Yes, because 13 is 9 more than 4. Then x would have to call 15, and he can because that's plus 2, and that is part of the criteria. So I hope you get the point here. I mean, that's basically all it is. And you just keep doing this. 12, yes, 15 plus 3. 11, yes, 15 plus 4. And then so on, all the way dot, 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 down to the last one, which is 5. Can y call a 5? Yes. And can x now call a 15? Yes, because 15 is plus 10. So that's basically the strategy. So let's write out the strategy in words. And it would be as follows. Except for 15, except for numbers greater than or equal to 15, numbers, I guess, be complete there, which are not allowed according to the rules of the question, because the number has to be anywhere from 1 to 10. Under the rules, right? No matter what Yolanda calls, y calls, Xavier can win by simply just calling a 15 according to this table. So look this over and understand it. It's really not that complicated, and make sure that when you write something like that, make it as complete as possible. This is sort of the basic version, but if you want to explain it further, you should. And that is the strategy that Xavier can guarantee that he wins. And I think they put the guarantee in there. Explain why Xavier has a winning strategy. Okay, well, whatever. So that's the winning strategy. According to the rules, you follow this process. Part B, the second time the game is played, the person who calls the number 50 is the winner. If Xavier goes first, how does he guarantee that he will win? Okay, so this is where they use the word guarantee. Okay, so let's see what we have here. So the same kind of story, really, and what I originally kind of looked at was the fact that you really have to just use the strategy we just created. You understand what I mean? Or no, if you don't understand, I'll explain it. So before I jump to the answer, it might not be as obvious for you, so I'll do a little bit of experimentation, right? So Xavier is going first. Now in the previous part, we showed that he can go from 4 to 15 in a numerous ways, right? And that is a increase of 11, right? You saw up here that this strategy right here guarantees that no matter what Yolanda picks, he can always pick 15 because it falls within the rules. So he can go from 4 to 15 guaranteed. Okay, that's the strategy we're going to use in this question. But our end goal this time is not 15, it's 50. Now we don't know what number he's starting at because the question doesn't tell us what number he starts at. It just tells us that they want us to come up with a winning strategy. So I think that we can just use the same strategy that we used in 2A of this question. So same strategy. And try to get to 50. Okay, so let's see what happens. Let's start at 1. Let's say he started at 1. If he starts at 1 and uses the same strategy, he can always go plus 11. So he can go to 12, which is plus 11. Then once he's at 12, he can use the same strategy to get to another plus 11, which would be 23, right? And then he can use another plus 11 to guarantee that he can get to 34. And then the same strategy can guarantee that he goes to another plus 11, which is 45. And then after that, well, whatever, right? He can get to another plus 11, which is 56. But we don't want to get to 56. We want to get to 50. So you say, oh, it didn't work out that perfectly. Okay, but can I get this final number to be 50? And the answer is yeah. A lot of it just depends on where you started. So if I start at 1, I can get to 45. I want to get to 50, so let me start at another 5, right? So that would be start at 6. Now what happens? I use the same strategy to get to a plus 11, which would be 17. Then same thing. You guys get the idea, 28. Then the same thing. You get to 39, and then the same strategy again, and you will get to 50. So in words, and like I said, you guys could be as detailed as you want. Therefore, if Xavier starts at 6, then uses the same strategy as in 2A of this question. Yeah, this is 2B, so the strategy we showed in 2A to get to 17, which is this guy right here. Then he can use, again, the same strategy to get to 28, 39, and eventually 50 to win. And that's it. So it takes a little bit of thinking, and obviously you need to incorporate part 2A into this question, and that's the whole point. I mean, that's why 2B came after 2A, because it was a natural progression. Number 3, in the diagram ABCD, it is a square, and the coordinates of A and D are shown. The point P has coordinates 10, 0. Show that the area of triangle PCB is 10. Okay, so let's see here. PCB, all right? Let's draw a dotted line from B down to there. So whatever the coordinates of B are, that is going to be right approximately there. Now, I don't know the coordinates, but the fact that it's a square really helps. So A to D looks like it's going from 4 to 8, so that means that is 4. So therefore, all the sides have a length of 4, since all the sides of a square have the same length. Therefore, to get from A to B, I've got to go from 1 to something. Well, obviously, I've got to go to 5. So this point on the x-axis has got to be 5, 0. And B is going to have the coordinates 5, 4. So I'll just write that up here, 5, 4. And C, well, that's going to have the same x-coordinate, but then the y-coordinate would be 8, 5, 8. Yeah. Okay, I don't know if we need that or not, but let's see. So the area of triangle PCB, that's 1/2 base times height. We can use this as the base, and we can use this as the height. So the base is obviously 4. That's just CB. And the height is going to be from this 5 to this 10. So that's 5. And there you go. So this looks like 10. So that's exactly what they wanted. They just wanted you to show that. All right, so that's part A. Let's go to part B. Point E, which they are calling A0, is on the x-axis, such that the triangle CBE lies entirely outside square ABCD. If the area of the triangle is equal to the area of the square, what is the value of A? So we have to put E somewhere. So I'll just put it out here. Let's say it's somewhere here. So this is E, and it's A0. Okay. Let me see if I can squeeze that in here. So it's A and 0. Okay. And then they're saying that, what are they saying here? CBE. So CBE. So this time you're joining like that. Okay, so let's see what we can do here. And what do they want? The area of the triangle. Okay, so that's going to be 1/2 base times height is equal to the area of the square. Well, the area of the square, well, that's just 4 times 4. Okay, so that means BH would be 16 times 2, which is 32. Or actually, let's just keep it 16. I don't want to get it mixed up. So we have to show that 1/2 base times height is equal to 16. All right. So what is 1/2 base times height for that triangle CBE? Okay. Well, the base is this guy right here, so that's just 4. And the height is from here to here. Now that's going to be A minus 5. Right? So that's about all we can do there. And we are told that that's equal to 16. So then we have to solve for A. Okay, shouldn't be so bad. So this is 2 times A minus 5. So 8 is equal to A minus 5. So that means A is equal to 13. And that's all that is. And part C. Let's see here. Show that there is no point F on the x-axis for which the area of triangle ABF is equal to the area of ABCD. All right. So they're introducing another guy here, an F. Okay, so they're saying it's somewhere on the x-axis. So I don't know, where are we going to put it? Well, let's just put it here. Let's say that's F. And then they're saying that now we've got this other triangle, and we have to somehow show, what is it, ABF? Yeah, ABF. So A joined F, and then I've got to join the other guy, which is B. So that's ABF. Okay, so let's work this out. Show that there's no point that the area of triangle ABF is equal to the area of the square. Okay, so the area of the square, we already know. That is 4 times 4. So ABCD is 4 times 4, which of course is 16. And then the area of ABF, that would be 1/2 base times height. And I guess we have to use this as the base. And the height is going to be from there to there. So the base is just 4, right? And the height is going to be, B is, what are the coordinates of B? 5 and 4. So the height is just 4, right? Yeah. So that means that's 4 times 4 divided by 2, 8. So 16 obviously does not equal 8. So regardless of where f is placed on the x-axis, the height will always be 4, and the base will always be 4 for triangle ABF. So the area is always going to be 8. So you can write that out. I'll write it out. So in a sentence or so, we can write it all out. Basically, regardless of where f is placed on the x-axis, the height of triangle ABF will always be 4, and the base will always be 4, and therefore the area of triangle ABF will be 1/2 4 times 4, which is equal to 8, which is not equal to 16, which is the area of the square. For a set of numbers 1, 10, and 100, we can obtain 7 distinct numbers as totals of one or more elements of the set. These totals are 1, 10, 100, 11, 101, 110, and 111. The power sum of the set is the sum of these totals. In this case is 444. How many distinct numbers may be obtained as a sum of one or more different numbers from the set 1, 10, 100, 1000? Calculate the power sum for the set. So for this one, I think we can just do it manually. Let's make a little table. How many numbers? How many, let's see here. Yeah, numbers from the set that we're going to use. And then the examples, since there's so few, we can list them all. And then the sum. So here we go. Okay, so if I'm only, this is my set right here, right? So if I'm only going to choose one number, then what are the examples? I can choose 1, 10, 100, or 1000. Correct? And the sum of each of these the sum is just 1, the sum is just 10, the sum is just 100, the sum is just 1000, right? And the total sum here is 1, 1, 1, 1. Okay, so far nothing really that exciting. Okay, what about if I choose two numbers from that set? So examples are 1 and 10, 1 and 100, 1 and 1000, or 10 and 100, 10 and 1000, and then finally 100 and 1000. Now these sums are, let's see, 11, 101, 1001, 110, 1010, and 1100. And this whole sum is 3333. Okay. Hey, you guys get the point here. So let's keep going here. When I choose 3, I can have a 1, a 10, and a 100. I can have a 1, a 10, and 1000. I can have a 1, a 100, and 1000. Or I can have a 10, a 100, and 1000. And these sums are 111, 1011, 1101, 1110, and this whole sum is 3333. And finally, if I choose all 4, then I'm basically just choosing 1, 10, 100, and 1000, and that sum is 1111, and that sum is 1111. So that's how you do it. Now, these numbers here, I'll show you a way. I know this is only grade 9, but some of you more advanced students may know this, that you can figure this out. There's 4 numbers in that list, right? So from 4 numbers, you choose 1, and that is equal to 4. So that's how we got 4 here. If you're not familiar with choose notation, I encourage you to look it up, but it's a really nice way of figuring out these numbers. So from this guy right here, from 4 numbers, you're going to choose 2 this time, and that is equal to 6. And that's exactly what we got there, 6. For this guy here, from 4 numbers, you're going to choose 3. And 4 choose 3 is equal to 4. And that's what we got here. And finally, from 4 numbers, you choose 4, and that's equal to 1. And that's why we only had one such way of doing that. So that's about as complete as I can make this. And now the power sum, of course, which is what they want, is the full total. This guy, this, and this. And that full total is, I believe, 8888. So there you go. And I noticed something, and don't be discouraged if you didn't notice this, because I'm not in grade 9. I mean, I have a university degree in math. But this looks like a 1, 3, 3, 1 pattern, where this is 1 times 1, 1, 1, 1. This number here is 3 times 1, 1, 1, 1. This number here, 3 times 1, 1, 1, 1. And this is, of course, just 1 times 1, 1, 1, 1. Now, you might think, well, who cares? That doesn't help me in any way. And just kind of looking at that, this seems to be some sort of a pattern, and it seems to be a palindrome. Like, this is the same as this guy. This is the same as this guy. All right, so I just want to kind of make you think that way. So now that you have thought that way, let's move on to the next question. Determine the power sum of this set: 1, 10, 100, 1,000, 10,000, 100,000, 1 million. Okay, so we're going to do the same thing, but this time, hopefully, we don't have to do it all manually. So again, we got how many numbers from the set, how many sums, and then the total. And let's just put the set. It was 1, 10, 100, 1,000, 10,000, right? And what did it go up to? What did it go up to here? 1 million. Okay. 1 million. So 10,000, 100,000, and finally 1 million. Okay, so that's the set. All right, here we go. Let's see what we get. So how many numbers? Well, you can choose either 1, you can choose either 2, 3, 4, 5, 6, or you can choose all 7. Now, I'm not going to manually write them out because there's way too many. So that's where that choose notation comes in to help us. How many sums? From 7 numbers, I'm going to choose 1. And that is equal to 7. So there you go. In a very quick way, without having to do it all, I can get that. From 7, choose 2. That number is 21. Now, if you're not familiar with choose notation and you're getting kind of angry with me, let me just explain how you do choose notation. So 7 choose 2. How do you do that? It is 7 factorial over 7 minus 2 factorial over 2 factorial. And this would be 7 factorial over 5 factorial over 2 factorial. So this would be 7 times 6 times 5 times 4 times 3 times 2 times 1. This 5 factorial is 5 times 4 times 3 times 2 times 1. And the 2 factorial is just 2 times 1. The good news is that all those cancel. So you're just left with 7 times 6 over 2. And that is 21. Got it? So that's how I got 21. Okay, let's just keep going. 7 choose 3 is 35, I believe. 7 choose 4 is 35 again. Hopefully I haven't made any mistakes. 7 choose 5 is 21. 7 choose 6 is 7. And 7 choose 7 is 1. And although it's not required in this question, if you chose 0, it would be 7 choose 0. And that is equal to 1. So as you can see, there's a cyclic pattern here. Well, actually, cyclic is not the best word. Palindromic pattern. This 1 is the same as this 1. This 7 is the same as that 7. 21, 21, 35, 35. Got it? So hopefully I haven't lost anybody yet. Now, since there's so many, I'm not going to do what I did in the previous question, right? The previous question, there weren't that many, so I just wrote them all out. There's 4 here, 6 here, 4 here. I wrote them all out, and I manually made the sums, right? I'm not going to do that here because that's way too many. You really want me to write out 35 of these? It was way too time consuming. So let's do the easier ones, and let's see what we get. The easier ones are as follows. This one here, if you choose only one. If you choose only one, you're going to have examples, like I'll just put examples in here. If you choose only one, you could have chosen a 1 or a 10 or a 100, right? Just these guys here, all the way down to a million. And therefore, the total sum of these guys, we just add them up. So you're just adding 1 plus 10 plus 100 all the way up to a million, and that total sum is 1, 1, 1, 1, 1, 1, 1. Got it? Now, because this has a cyclic nature to it, the same sum will hold true down here for this guy. Now, I'll explain that. From 7, you're going to choose all 7. So that means you're going to have a set that's 1 plus 10 plus 100 plus ... all the way to the million, right? And that sum is 1, 1, 1, 1, 1, 1, 1. So it's the same as that. So as you can see, that cyclic pattern, or I keep using the word cyclic, that I don't know what, palindromic pattern is true so far. My guess is that this guy, whatever it is going to be the same as this guy. These two are going to be the same. And then these two will be the same. And then this will be its own thing. And that's the challenge of this question. Let's just do one more. Let's do this one here. From, which one's the next one? I'll do this one here. I think this will be fairly easy because there's only 7 of them, right? So I can do 7. You're choosing 6 of these 7. So in each one, you're going to leave 1 out. So that means you're going to have either 1, 1, 1, 1, 1, 1, 0. The sums, like for example, if I chose these 6 and I added them up, this would be the total. You got it? So similarly, I'm going to write out all the other sums. So there should be 7 of them, right? Well, because it's 7 right there. So that's the next one. And then there should be another one, 1, 1, 0, 1, 1, 1, 1. And then 1, 1, 1, 1, 1, 0, 1. 1, 1, 1, 0, 1, 1, 1. 1, 0, 1, 1, 1, 1, 1. And then 1, 1, 1, 1, 1, 1. Okay, so all I did to get these numbers was I chose 6 of these 7 and then added them up. And this total is 6, 6, 6, 6, 6, 6, 6. So therefore, this one is going to be 6, 6, 6, 6, 6, 6, that whole thing. Okay. Well, now our great challenge is to come up with this number here, and this number, and this number. And that's going to take a lot more time, right? So I thought about this, and I said, do I really want to manually do all these? I mean, so far it's not so bad, right? So far it didn't take that much time. But to do this one, and this one, there's a lot, 35, 35, 21. So I put it, I looked at this and said, okay, this looks like to me, obviously, it's 1 times 1, 1, 1, 1, 1, 1. This is obviously 6 times 1, 1, 1, 1, 1, 1, 1. And then this is obviously 1 times 1, 1, 1, 1, 1, 1, 1. And this is 6 times 1, 1, 1. Well, you understand. So I've got this 1, 6, and then 6, and then 1 pattern. The previous pattern was 1, 3, 3, 1, right? So I thought, and then it hit me. And the good news is that to figure out what this is, these 3, it's actually not that complicated. Even somebody in grade 9 would know. And that is something called, some of you may have heard of this, binomial expansion. That will give you the numbers. And I'm confident that every single one of you will understand. So here we go. You all know how to expand a plus b squared, right? It's a squared plus 2ab plus b squared if you expand and collect like terms. Now, what are the coefficients? This is 1, right? If it's 1, you don't write it in. So the coefficients are 1, 2, and 1. This is 1, this is 2, and this is 1. Okay, great. This is one binomial pattern. Now things get a little bit more interesting when you go to a plus b to the third. When you expand this and collect like terms, you get a third 3a squared b plus 3b squared a plus b to the third. What are the coefficients here? 1, 3, 3, 1. Have you seen a 1, 3, 3, 1 pattern somewhere? And the answer is yes, you have. Where have you seen it? You've seen it right here. This one that I did in the very beginning. It was a 1, 3, 3, 1 pattern. So there you go. So to get this one, what is this pattern going to be? Right here, you would have to use the binomial. Now I kind of know so far it's going to be 1, 6, something, 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 6, 1. Okay. So that's 7, right? 7 coefficients. So this is 3 coefficients, this is 4 coefficients, 5 coefficients, 6 coefficients, 7 coefficients. So that means I'm going to have to go to, this will be 4, this will be 5. I'm going to have to go to a plus b to the power of 6 in order to get 7 coefficients. Okay, and when I do and collect like terms, you'll get the following. Now, I'll do this one first. You guys can expand and collect like terms. I'm confident that you can do that. You don't need to hear me do it. But when you do, and then you just do the coefficients, for a plus b to the power of 4, it's 1, 4, 6, 4, and 1. For a plus b to the power of 5, it's 1, 5, 10, 10, 5, 1. And then finally, this one that we are most interested in, it is 1, 6, 15, 20, 15, 6, and 1. So these guys we got already, right? It was just these ones that we needed to figure out. And with binomial expansion, we got it. 1, 6, 15, 20, 15, 6, 1. So going back to the question, we can very proudly fill it in. The 1 and 6 we got, but this was 15, this is 20, and this is 15. So that basically means this is 15 times 1, 1, 1, 1, 1, 1, 1. This is 20 times 1, 1, 1, 1, 1, 1, 1. This is 15 times 1, 1, 1, 1, 1, 1, 1. So the power sum is the total. So all of these are factors of 1, 1, 1, 1, 1, right? 1, 1, 1, 1, 1, 1. And then multiply it by 1 plus 6 plus 15 plus 20 plus 15 plus 6 plus 1. And that to me is, what is that, 64? 20 plus 30 is 50, 50, 60, yeah, 64. And then if you multiply that out, it is 7111104. And that is the power sum. So it's a very, very good question. And I encourage you to learn some of the things that you may not have known, like the choose notation, 7 choose 2, that kind of notation. And then the binomial expansion, which I'm pretty confident that somebody in grade 9 would be able to understand.